All right, so we're going to start off with some work problems. You guys explored this concept yesterday with just the one problem about mowing the lawn. And so we're going to continue. We'll continue that that concept today. If you remember at the end of class, we talked about how we can set up rates where it's like the amount of work, which was one job, over the amount of time that it takes to do that job. So they look like fractional problems where we created a rational equation that we would then solve. So in this problem, this example that we're going to do, we actually have 3 machines working together, not just 2. So let's say we have machine A, and machine A does a job in 10 hours. Machine B can do the same exact job. It takes it 15 hours. And machine C can do that job in 20 hours. And then the obvious question is, all right, if they're working all together, how fast can they do the job? Right? And so let's talk about how we would set up this type of an equation. Let's first start off by creating a rate for each one of their jobs, right? Each machine. So machine A does one job in how many hours? 10. So what would that look like? 1 over 10 for machine A. How about machine B? 1 over 15. And machine C? 1 over 20. And if all 3 of those work together, that means we're adding them. They would do one job in, I don't know, that's where we get our X. Does that make sense? So there's your setup. Let's go ahead and solve. All right, so you guys said our LCD is 60x. So did you multiply everything by 60x? You should have. 60x. And in doing that, you should always have your denominator simplify. So we have 6x here. How much?
2x.
No, 4x. Okay. And this one? 3x equals, here the x's simplify, 60. And we add everything up. 13x. And divide. We're not going to get a nice whole number. But that's okay because you all have calculators. What do you have? 4.6. 4.6 what? Hours, yes. So it takes 4.6 hours for these 3 slow machines all working together to get the job done. Make sense? All right. Now every problem is not the same setup. It is not always this can do it in this many hours and this does it in that many hours. Put them together. All right. It's not always the same setup. For example, we can go back to mowing lawns. Let's say we have Wilma and Fred, the Flintstone family, right?
No.
You don't remember the Flintstones? Fred and Wilma? All right. Go back on Boomerang and watch some little Flintstones, right? So Wilma can mow the lawn in 3 hours by herself. Together, Wilma and Fred mows the lawn in 2 hours. So what do you think the question's going to be? How long does it take Fred to go by himself, right? All right. All right, so how long for Fred alone? So what does the setup look for this problem?
1 over 2 minus 1 over x equals 1 over 3.
That could work. Let's try to keep with the same setup that we've done every time. Remember, like that verbal model we talked about earlier in the year? We've kind of come back to that idea that if we take Wilma's rate plus Fred's work rate, they get the together work rate. So if we keep with that same concept, that might be actually what we end up doing, is using subtraction. But if we keep with that same concept of Wilma's work rate, that's hard to say, plus Fred, right? They'll get the together rate. Does that make sense? So this is what we call a verbal model. It's when we write out in words what you need to do. What's the relationship between these things? And that's going to help us a lot today in our word problems. All right, Wilma's work rate. She gets one job done when? 3 hours. Fred's? 1 over X. We don't know. But their together rate is? 1 over 2. We're not going to go ahead and solve this. You guys know how to solve it from here. Just want to make sure that you know how to set it up. Okay? All right. Another type of problem that you might see. The old swimming pool has a leak problem. Okay, so here's our above ground swimming pool, and we're going to fill it up with a hose, right? So the hose is filling it up, and it might take, let's say, 10 hours to fill up this swimming pool. And we find out that right there along the bottom that there's a leak. And the leak is letting out water. And we don't have a patch, right? And we're like, forget it. We're just gonna keep filling up the water anyway. It's a slow leak. In fact, we figured out that if the water was all the way filled up, it would take that leak 24 hours to empty out the pool. So it's a pretty slow leak. So the question is, if I'm just going to fill up this pool, even though it's leaking out, how long would it take me to go ahead and get this thing filled up to the top? What would this equation look like? The 10 hours is how long it takes the hose to fill the pool. What type of problem would this be? How long would it take us to fill the pool? Even though I'm losing some of the water, the minute I start putting in the water into the pool, it starts leaking out. It's going to be a subtraction. Yeah, you're right. So what's the rate of the hose? 1 over 10. And then what do I write? Minus 1 over 24, because that's the leak. And we will know then how long it takes to fill up the pool. So sometimes it's a subtraction if it's working against itself. So I just want to make you aware of how those, could be set up. I don't want you just to see a problem and be like, oh, it's a work problem, and just do 1 over one number plus 1 over the other number equals 1 over X. Every problem is not set up that way. You really do need to read the problems carefully and see how that works. All right? On the worksheet that I give you for today, there's going to be 2 problems that were going to be a little worded differently than ones that you haven't seen before. And I would like you to try it first. We're going to cover those 2 problems tomorrow. You'll probably be able to figure out which ones I'm talking about, because you'll be like, whoa, we haven't done ones like this before. That's on purpose. Remember Einstein? Teachers help too much. Sometimes in the struggle is where you really begin to understand some things. All right, so those are your work problems.